So a friend tosses you a softball of mass m sub ball with a velocity of v sub ball initial in the x direction. You swing a bat of mass m sub bat, and just before impact, the bat has a linear velocity of v sub bat initial in the negative x direction. After a collision with the bat, the ball has a new velocity of v sub ball final in the negative x direction. Assume this collision is inelastic. So I'm drawing a picture on the bottom here just to show the negative x direction and the positive x direction. There is the ball with the v sub ball initial, and then here's the bat with the velocity sub for the bat, the initial velocity of the bat, sorry. Also, remember that we're assuming that this is an inelastic collision. So our first problem here is to find the ball's impulse. If you remember from our equation sheet, impulse is just equal to the change in momentum, which can be written as the mass times the final velocity minus the mass times the initial velocity. This can be rewritten or just simplified into the mass times the final velocity minus the initial velocity. And really, that's it. In the most simplified terms, that is what our impulse is. So for our second problem, we're finding the velocity of the the bat after the collision. So we should take into account the fact that this is an inelastic collision with no external forces. And because of that, we can conclude that momentum is conserved in this equation. So that means that the change in momentum is equal to 0, and that the initial momentum is equal to the final momentum. So we're going to be using the kind of format we saw on the equation sheet, where the mass of the ball times the initial velocity of the ball plus the mass of the bat plus the initial velocity of the bat is equal to the mass of the ball times the final velocity of the ball plus the mass of the bat times the final velocity of the bat. And remember, the final velocity of the bat is what we're ultimately solving for here. And really, to make sense of this equation, on the left side, that makes up our initial momentum. And then on the right side, that's our final momentum. And really, you can think of that equation, the equal sign, as the point of the hit. And really, it's just a matter of doing some algebra to get to the value for the final bat velocity. Ignore the fact that I put in a plus sign instead of a multiplication sign with the mass of the bat times the final velocity of the bat. Pretend that's a multiplication sign, it'll fix it pretty soon. Anyway, after all of that algebra, this is what we're going to get for our final answer. The velocity of the bat after the collision. And there it is.